Okay. Oh. Then, so yesterday was a demo class. Okay. Then, so I just discussed just what is this course like. But regular class starts from today. And before going to the actual SQL server, okay, we'll start with some basics. What basics means? Database basics, database fundamentals. So that is, so what is database? What is DBMS? The basic definitions. Okay, no. So then we'll start with, so what is database? Okay, na? Then, so what is the definition of databases? A database is a organized collection of interrelated data. So it is a organized collection of interrelated data. Then, okay, na? So then, if you see this definition, in this definition, there are two terms. One is interrelated, another one what? Organized. So what is interrelated is, what is interrelated means, what is organized means. So in yesterday's class, what we discussed is databases. Every database stores what? Data. Database stores data. Databases are used for storing the data. Suppose you take, for example, this is bank database. A bank database stores data related to what? Customers, data related to accounts, data related to transactions, data related to loans, and data related to employees. Okay, then, so bank database stores customers data, accounts data, transactions, loans, employees. What is this is? This is interrelated. Customers are interrelated to accounts. Accounts is interrelated to transactions. So a database stores what? Interrelated data. For example, you take what? University. Suppose university database. A university database stores data related to what? Data related to students, data related to courses, data related to faculty, data related to colleges, like this. What is this is? This is what? Interrelated. Students are interrelated to course. A course is interrelated to faculty, like this. Okay. But a bank database, it doesn't store data related to university students. A university database doesn't store data related to bank database. Okay, now a bank database doesn't store data related to university students. A university database doesn't store data related to bank customers. So because that is not related. Okay, then. So that is the meaning of what? Interrelated data. And also what? Organized. So what is organized means? Okay, what is organized means? Like not only storing the data is important, the data should be organized. If the data is not organized, accessing data is what? Difficult. If data is not organized, accessing is what? Difficult. Example, you take library. Okay, na? Engineering college library. See, in library, all books are in one rack. Okay, na? Computer science, electronics, electrical, mechanical, all books are in one rack. If all books are in one rack, what the problem is? Finding the particular book is what? Time taking. Yes or no? Finding the book is time taking. So then suppose you keep separate racks, one rack for computer science, one rack for electronics, one rack for electrical. If you keep separate racks, then finding the book is what? Easy. So similarly, in database, not only storing all this data is important, the data should be what? Organized. So how the data organized in database? Like this is the database. In database, you organize the data by using tables. The data organized by using tables. Suppose then student data stored in one table, course data stored in one table, faculty data stored in one table, colleges data stored in one table. So separate tables. The data stored in what? Separate tables. So you want to access student data, then go to the student table, access the data. You want to access course data, then go to the course table, access the data. You want to access faculty data, then go to the faculty table, access the data. Accessing is what? Easy. So in database, how the data organized? By using tables. In libraries, books are organized by using racks. In database, data organized by using tables. Okay, then. So now, so for example, then a bank database stores data related to students, customers, accounts, transactions, etc. Okay, and a bank database and university database stores data related to students, courses, faculty, etc. Okay, then no. Okay, no. So what are the, even in yesterday also we discussed it, what are the different types of what's it? Databases. Okay, one is what? One is OLTP, another one OLA. So there are two types. So every company maintains two databases. Nowadays, every organization maintains two databases, OLTP and OLA. What is OLTP stands for? Online Transaction Processing Database. OLTP stands for Online Analytical Processing Database. It is also called DWH. DWH means data warehouse. This OLAP database is also called data warehouse. Okay, then you can call it as OLAP or you can call it as DWH, warehouse, data warehouse. Then now see what for companies use OLTP, what for companies use OLAP. The first one is used for what? The first one is used for storing day-to-day transactions. The first one is used for storing the day-to-day transactions. And the second one is used for what? Analysis. Okay. Then first one is used for day-to-day operations. Second one is used for analysis. If company wants to, then bank wants to run the business. If bank wants to run the business, they use OLTP. If bank wants to analyze the business, they use OLA. Okay, for running the business, they use OLTP. For analyzing the business, they use OLA. Sometimes if we go to bank says server is down, wait for 10 minutes. Which server is down? Bank OLTP server is down. When OLTP server is down, it will not allow the transactions. When server is not allowing the transactions, bank employees also, they don't take transactions from customer. They'll ask them to wait because it is not accepting, because this is down. Okay, na? Then organizations uses OLTP for storing day-to-day transactions and OLAP for analysis. Okay, then next, OLTP is for running business and OLAP for to analyze business. Okay, then next. So what are the day-to-day operations on database? Okay, what are the day-to-day operations? The day-to-day operations on database includes what? Any database you take, what are the day-to-day operations? Mainly 4. C, R, U, D. Mainly 4. What is that 4? Create, read, update, delete. Okay, na? So any database you take, the day-to-day operations are 4. Create the data, read the data, update the data, delete the data. So create, read, update, delete. Okay, then you take bank. A new customer opens account. Then when a customer opens account, his details are created. And customer want to check the balance. That is called reading. Customer deposits some amount. His balance is updated. Customer wants to close account. Delete. So any database you take, every day you perform this. Store, read, update, delete. Okay, na? Then now. So, but can you suppose, for example, okay, suppose, for example, this is the database, for example, like 1 second. So this is the database. Okay. So university database. Then, for example, can you directly perform these operations? CRUD. Can you directly work with the database? Suppose I want to store some new students data. You want to store some new students data. Then can you directly store the data in database? No, that is not possible. You cannot directly work with database. You cannot directly operate the database. Okay, na? User cannot directly operate database. User cannot directly work with database. You need one software. You need a software to work with the database. What that software is? Okay, you need a software to work with the database. What that software is called? That software is called what's it? DBMS. What the software is? DBMS, Database Management System. Okay, then. So what the next one is? DBMS. I'm just giving the basics. Oh. So what is DBMS stands for? DBMS stands for Database Management System. Database Management System. Then what is this is? And it is a what? What it is? It is a software. Okay. Software used to create and to manage database. And what for DBMS is used? DBMS is used to create and to manage database. Managing means to work. If you want to create the database, if you want to work with the database, then you use DBMS. In your laptop, you want to create the database, you want to work with the database, then you use DBMS. So like you purchase a new laptop. The new laptop comes with what? Hard disk. Can you directly work with hard disk? The new laptop comes with hard disk. Can you directly work with hard disk? No. First install OS. After installing OS, then you can work with hard disk. So that means you work with hardware components through operating system. Similarly, you work with the database through DBMS. So that means you can say like user uses what? DBMS to work with database. Then you can say, so DBMS is an what? DBMS is an interface between user and database. So you can't directly work with database. You work with the database through a DBMS. Then, so but see this, what are the like evolution of DBMS? Evolution of DBMS. What is evolution means? What is the evolution? Evolution means like suppose, for example, I go to evolution of what? Suppose telecommunication. Evolution of telecommunication. You see this? Then you see this. This is evolution of telecommunication. That means in the very beginning, which phones are used? Next, how you do the communication? Next, which phones? Next, which phone? Next, which phone? Now, smartphones. So, what this is? Evolution of what? Telecommunication. So, then what is evolution means? Evolution means step by step development. Evolution means what? Step by step development. Okay, like that. What is the step by step development in DBMS? So in the very beginning, okay, 1960s, companies used FMS for data storage. In the very beginning, companies used what? FMS for data storage. 1970s, companies used what's it? HDBMS. Next one, they used what? NDBMS. 1980s, what? RDBMS. 1990s, RDBMS. So this is evolution of DBMS. So in the beginning, what systems were used for data storage? Next what? Next what? Next what? Okay, then. Then So what is FMS stands for? Okay. What is FMS stands for? File Management System. FMS stands for File Management. What is HDBMS stands for? Hierarchical DBMS. What is NDBMS stands for? Network DBMS. RDBMS stands for Relational DBMS. What DBMS stands for? Object Relational DBMS. Okay, then. So file management system, hierarchical DBMS, network DBMS, relational DBMS, object relational DBMS. So this is the step-by-step developments in what's it? Databases, DBMS. Okay, now, but frankly speaking, these are outdated. The systems are what's it? Outdated. They are not in use. At present, no company using what? FMS, no one using HDBMS, no one using NDBMS. So every company uses RDBMS and RDBMS. Okay. Then see, then actually, sir, what is the difference? One DBMS to another DBMS. What the difference is? The difference is the how you organize the data is different. In HDBMS, they use one structure. They use one structure for organizing the data. In NDBMS, they use a different structure. In RDBMS, they use different structure. So one DBMS to another DBMS, they use a different structure. Like suppose, for example, then you take suppose HDBMS. In HDBMS, the data organized like this. In HDBMS, they organize the data like this. Then they organize the data like this, means like this. What is this? What is this is called? This is called hierarchy. This is called hierarchy, or this is called tree structure. This is called hierarchical, or this is called tree structure. So this is the structure they use it in HDBMS. In HDBMS, this is the structure they use it. Okay, na? But this structure is complex. This is what? Complex. Okay, why? Because you want to access the data stored here. If you want to access the data stored here, you cannot directly go to this point. You have to start from here. You start from here, then go to this. You start from here, go to this. Then you cannot directly move to this. You have to start from here, next this, like that. Okay. Then next, suppose network. There is next one. Next one, what? They use another structure. What is that structure is? This one. In NDBMS, they use it this one. What is this is called? Nodes. They use it what, sir? They use it nodes. That means here, this node is linked to this. This node is linked to this. This node is linked to this, like that. They use it this one. What is this is called? NDBMS. This is called hierarchical. Then what is this is called? Network. In RDBMS, what the structure they use? In RDBMS, they use this structure. What is that is? In RDBMS, they use this structure. What is the structure? Table. Okay, na? Then. So, that. Table. Okay, then. So, which is simple? Which is simple structure is Table is simple structure. So that is the reason RDBMS became popular. RDBMS became popular. When RDBMS is introduced, most of the companies what started developing what's that RDBMS softwares. Earlier in hierarchical network, okay, hierarchical DBMS is there only from IBM. Network DBMS is there from IBM. Okay, na? That means IBM was the king in databases. But once RDBMS is introduced, most of the companies introduced what's that RDBMS databases. Okay, na? There is a DBMS from Oracle. There is a RDBMS from Microsoft. There is a RDBMS from IBM. So number of companies introduced because of what? Simple structure. A number of companies migrated from old systems to what? RDBMS. Okay, then. So because of its simple structure, most of the companies migrated from FMS to RDBMS, HDBMS to RDBMS, NDBMS to RDBMS. Okay, then. Okay. So now, but in this, sir, we don't need to discuss about this. Like what we discuss about what you need. You need only two. What are the two? RDBMS and RDBMS. Then and RDBMS, RDBMS concepts, RDBMS concepts are introduced by a person called EF card. Okay. Then concepts are introduced by a person called EF card. Okay. Then and but how we introduced RDBMS concept? EF card introduced what? 12 rules. EF card introduced 12 rules. They are called what? Card rules. Sir, oops is there. Oops comes with some features: abstraction, encapsulation, inheritance, polymorphism, like that. So similarly, RDBMS comes with some features. Okay, then how many? 12. 12. So any database that supports 12 rules is called perfect RDBMS. A language that supports all the concepts of OOPS, then it is called perfect RDBMS. Similarly, a database that supports all features of RDBMS, then it is called perfect RDBMS. Okay, na? A database that supports all 12 rules called perfect RDBMS. Then so like actually, but this is not the right time to discuss all the 12 rules. Okay, then actually first rule is, what is the first rule is? Information rule. Information rule. What is the information rule? Then according to what? According to information rule, the data must be organized in what? Organized in what's that? Tables. That is rows and columns. According to this information rule, data must be organized in tables, rows and columns. In RDBMS, so compulsory the data must be stored in tables. Okay, then so then means like this. Okay. Oh, okay. Then like this. Suppose then, for example, okay, for example, sir, here in RDBMS, I want to store customers' data. How you store customers' data? You store like this. You store data like this. What is, how you store customer data in RDBMS? You store like this. What is customer? Like, for example, customer ID, customer name, customer address. Then, so ID, name, address. Then, next. So ID is what? ID is 10. Suppose some name, some address. Okay. Then, next ID is what? Suppose 11. Then some name, some address. ID is 12. Some name, some address. Okay. Then, so like this is how you store customer data in what? RDBMS. So in this table, rows and columns, what are these verticals are called? Okay, what are these verticals are called? These verticals are called what? Columns. These verticals are called columns. Then, so what is this is called? This is called what? Columns or fields or attributes. The verticals are called columns or fields or attributes. Here, how many fields are there? In this table, how many fields are there? 3 fields. One field is customer ID. One field is customer name. One field is customer address. Okay. Then, so verticals are called columns or fields or attributes. What is this horizontal is called? So these horizontals are called row. This horizontal is called row or record or tuple. So verticals are called columns or fields or attributes, and this horizontal is called row, record, tuple. Okay. Then, so in this table, how many records are there? How many records are there? Okay, na? How many records are there? In this table, how many rows are there? How many records are there? 3. See, first one is not considered what? Row. First one is not considered row. The first one is what? What the first one contains? Field names. The first row contains field names. This is not row. Then, so this is row. This is the row. This is the row. This is the row. So how many rows are there? 3 rows. Okay. Then in this table, there are 3 fields and 3 rows. Now, so what is each row contains? What is each row contains? Each row contains what? Row contains what? Data, values. Okay, na? The first row contains first one, 10. 10 is what? Value for ID. Sachin is value for name. Mumbai is value for address. So the row contains what? Values, field values. The row contains field values. The first row contains first customer's data. The second row contains second customer data. And third row contains third customer. In customer table, one row equal to, in customer table, one row is equal to one customer. In customer table, one row is equal to one customer because it contains one customer's data. Okay. Then, so like suppose, see, for example, you just leave it. What I'm doing, you just leave it this. Then, for example, then this is what? number, name, salary from. So this is employee table. This is what? Employee table. So employee table contains employees data. How many employees data is there? 14 employees. So this is how many rows are there? 14 rows. Each row contains one employee's data. His ID, his name, his salary. Okay, na? His ID, his name, salary. So what is this is? This is not row. What is this is? Field names. So how many fields are there? 3. ID, name, salary. Okay, then. So there are 14 rows. Each row contains one employee's data. His ID, his name, salary. Second row contains second employee's data. His ID, his name, salary. Like that, how many employees data is there? 14 employees data. Okay, then. So what is this is called? This is called table. Okay, then. So in RDBMS, data stored in the form of tables. Okay, then. So what EF card said, according to EF card, what is database is? Database is what? Collection of tables. He said database contains table. What is table contains? What is table is? He said table is a what? Collection of rows and columns. What is row? What is row is? A row is what? Collection of what? See, this collection, this is the row. What is this row contains? Collection of values. What is 7369? Value for number. What is Smith? Value for name. What is 800? Value for salary. Then what is row? Row is collection of what? Field values. Value for number, value for name, value for say, salary. Collection of field values. What is column is? Okay, na? Then. So what is column is? Address column. Okay, na? Collection of what's it? Collection of one particular field values. What is row is? Collection of different field values. ID, name, salary. Sorry, ID, name, address. So what is row is? Collection of. Row contains collection of values of same field or different fields. Different fields. ID, name, address. Then what is column contains? Collection of what? Same field values. Collection of one field value. Okay, na? Then. So collection of. Okay, na? Collection of values belongs to one field. Collection of values belongs to one field. So one particular field values. Okay, then that's all. Clear? No. Sir, for your course, what is important is these two. Your course, for your course, these two are important. These two are, this is not important for, nobody will ask. Okay, na? Then. So then next, one more point is, then I'm explaining RDBMS concept. Okay, what EF card said, every table must contain what? Primary key to uniquely identify the records. Every table must contain what? Primary key. Every table must contain primary key to uniquely identify the records. Okay, na? Then. So every table must contain primary key to uniquely identify. Okay, so what is this contains? Employees data. There must be a mechanism to uniquely identify the employees. In employee, you are storing the employees data. In table, you are storing employees data. When you are storing employees data, compulsory there must be a mechanism to uniquely identify. Then otherwise it is difficult to access the data. Suppose, for example, see, just listen. Bank stores customer data. Just listen. They store the customer data. They are storing like this: name, address, WhatsApp, balance. They are storing like this: name, address, balance. Then I'll go to bank. I'll ask, sir, what is my balance? Then they'll ask, what is your name? I give the name. My name is Vijay. They go to customer table, find the customer with name Vijay. But how many customer they can find with name Vijay? Number of. Then again they will ask my address. I give my address. Again they can find number of customer with same address house. That means if you store like this, what the problem is? Accessing individual customer balance is what? Difficult. That is the reason every bank introduced what's account number. What for? To uniquely identify the customers. If one account number is given to one customer, the same account number is not given to another customer. Now I go to bank. I'll ask, sir, what is my balance? Then they will ask, what is your account number? I give my account number. How many customer they'll find with one account number? Only one customer. That means, so account number is uniquely identifying or not? Yes. So what is this account number is called? This account number is called what? Primary key. Okay, na? So if table is there, compulsory what must be there? Primary key must be there. So every organization stores what? Employees data. Suppose they are storing like this. What is name, job, salary? They are storing like this. Okay. Okay. Oh. Okay, na? Name, job, salary. Okay, na? Then if they store like this, what the problem is? If they store like this, what the problem is? The problem is what? Like there may be number of employees with what? Same name, same job, and same salary. So that is the reason every organization uses what's that? Employee ID. What for? To uniquely identify the employees. So one ID is given to one employee, same ID is not given to another employee. So what is this CMP ID is called? Primary key. Okay, na? You see that here also. So what is that? Employee number. So there is no guarantee that names are unique. There is no guarantee that salaries are unique, but definitely there is a guarantee that employee numbers are always unique. So by using this employee number, we can uniquely identify the employees or not. Yes. So what is this is called? This is called primary key. So what is the example is? Example for primary keys. One is account number, employee ID. How Indian government uniquely identifies the persons. Other. So that is also primary key. How income tax department uniquely identifies PAN number. How election department uniquely identifies voter ID. So all these are examples for what? Primary keys. Their main purpose is to uniquely identify. Okay, then. So you go to like election website, voters. There is a call search by name is there, but you enter the name. Maybe you find number of voters with same name, yes or no? But search by voter ID, then only one. So that voter ID is what's that? Primary key. Okay, then next. So next one. See, what are the other features of RDBMS? Okay, na? What are the other features apart from what? Just we discussed two. What are the two? So data must be organized in tables. Every table must contain primary key. Apart from this, what are the other features? So one is then RDBMS. What's it? In RDBMS, easy to access and what manipulate data. So easy to access and manipulate the data. Accessing and manipulation is what easy. Accessing means reading. Manipulation means changing, update, delete. Okay, then less redundancy. Next one, more security. More security. Next one, more security. Next one, guarantees data quality. Next one, supports data sharing and supports transactions. Okay, then so now sir, easy to what access and what sir manipulate the data. Sir, earlier means before RDBMS. Before RDBMS means FMS, HDBMS, NDBMS. Before RDBMS. Then accessing manipulation is what difficult, because see, you want, for example, you want what's it? Create the data. You have to write a program. You want to read the data. You have to write a program. You want to update the data. You have to write a program. You have to delete the data. You have to write a program. So that means before RDBMS, that means in the systems, for every small operation, you have to write program. For reading, you have to write a program. For updating, you have to write a program. For deleting, you have to write a program. For creating, you have to write. For every small operation, you have to write what? Programs. That means you have to be expert in programming to work with the database. If you are expert in programming, then you can work with database. But now, when RDBMS is introduced, in RDBMS, for creating, you don't need to write program. There is a command is there. Insert command. Reading, there is a command, select command. Updating, there is a update command. Delete, there is a delete command. You don't write what, sir? You don't write what? Programs. You write commands. You write commands. You want to insert new employees data. You want to insert new employee data. There is an insert command. Okay, na? You want to update what, sir? Salary 800. I want to change the salary to 1000. Then you write update command. Update EMP set salary equal to 1000, where employee number is 7369. You write update command. Okay. Then you write update command. So salary changed to what? 1000. Earlier salary was what? 800. Now the salary changed to 1000. I want to delete this employee row. Okay, na? There is a command. What is that? Delete from EMP, where employee number is 7369. So the row is what, sir? Deleted. Now, how many rows are there? How many rows are there? 13 rows. One row is what? Deleted. Okay. So that means here you write what? Commands. You don't write any programs. So then working is easier, not? Yes. So that is why easy to access and what's that? Manipulate. That means even if you are not expert in programming, but still you can work with database. Okay. So those who are not expert in programming, but can work with database. Next one. Less what? Redundancy. What is redundancy means? Duplication of data, repetition of data. What is redundancy means? Duplication, repetition of data. Okay, then. So what is this? What is this redundancy is? Okay, na? What is this redundancy? Sir, here, suppose, sir, earlier, you take example, suppose bank. So this is one department, this is one department, this is one department. So this department, what is this is home loans department. This is car loans department. This is gold loans department. Okay, then. So a customer is taken home loan. A customer taken home loan. Customer details are stored in this department. His account number, his name, his address, like that. Okay. The same customer is also taken car loan. His details are also stored in what? Car loans. Car loans department also stored the details. His account number, his name, his address. And gold loans department, he is taken gold loan also. So the customer details are stored in gold loans department. That means same customer details are stored in number of places. Yes or no? The same customer details are stored in number of locations. What is this is called? What is this is called? Redundancy, duplication of data, repetition of data. The same data is repeated in multiple locations. This is called redundancy. What is the problem? Redundancy. Okay, na? Memory wastage. Not one customer, thousands of customers taken all the three loans. Not one customer, thousands of customers taken all three loans. Then what is this is? Thousands of customer data is repeated or not? Yes. So what is this is called? This is called repetition of data. So what the problem is? Memory wastage. Okay, then. But when it comes to RDBMS, when it comes to RDBMS, then what we can do is, sir, here, this is the server. This is the server. In server, you store the customer's data, his number, his name, his address. Then what is this? This is home loans department. This is car loans department. This is gold loans department. All these departments are connected to, the server. Okay. That means your customer details are stored in how many locations? One location, a single location called server, and all the departments are connected to the server, and all these departments can access customers' data. So here, there is no repetition of data. There is no repetition of data. So redundancy is what, sir? Less. Okay. Then, so less redundancy. Then next, more security. Not everyone can access what? Database. Not everyone can access what? Database. Only authorized people can access what? Database. Okay. Then suppose, for example, I want to access what? Okay. I want to access what's it? Oracle database. To access Oracle database, what it is asking? What is asking? Username and password. So that means without giving the user ID and password, you cannot access what? Database. Security is there or not? Yes. So that you cannot access my database and I cannot access your database. Then suppose I want to access SQL Server database. So I want to access SQL Server database. Then here also what it will ask? To connect to the database. Then it will ask login and password. Okay, na? So it will also ask login and password. So without giving the login and password, you cannot connect to the database. That means security is there or not? Yes. Then so then another one more security. Next one, guarantees. What's that? You see this here. You see this. What it is asking? Login, password. Suppose I'm giving login ABC, password XYZ, password XYZ connect. Then it is giving what? Error. What is that? Is connection was successfully established with the server. Okay. Then, but the error occurred during the login process. Okay, na? That means invalid. You given invalid login and what's it? Password. Then understood? Then so what the next one is? Guarantees what? Data quality. So guarantees data quality. What is data quality is? Then what is the data quality means? Like 1 second. Suppose I'm storing employees data. Just see this. I'm storing employees data. Employee what? ID, employee name, employee what's that? Salary. You entered ID is 100, name is what? A, salary is what? 5,000. So this is one employee's details. His ID, his name, salary. Another employee, ID is 100, name is blank, salary is minus 3,000. Okay, na? I enter like this. Now tell me, this is valid or invalid? This data is valid or invalid? Invalid. Because this ID is already given to one employee. The same ID cannot be given to another employee. Name cannot be blank, empty. And salary should not be negative. Salary should be always positive. So this data is what's invalid. This data is what? Invalid. Okay. But if you take RDBMS, in RDBMS, there are some facilities to check the data is valid or not. Okay, na? Sorry, earlier means before RDBMS. Then, so to check data is valid or not, you have to write a program. Employee number is valid or not, you have to write program. Name is valid or not, you have to write a program. Salary is positive or negative, then you have to write program. For everything you have to write programming, completely programming this. But when it comes to RDBMS like SQL server, RDBMS, you don't need to write program. Simply declare what? Employee number, what's that? Primary key. Declare employee number as primary key. Then it will not allow. It will not allow what? Duplicates. If you try to insert duplicates, then it gives error. It will not allow. Suppose name is there. E-name. E-name, declare what? Not null. Null means blank, empty. Then if you declare not null, then what is not allowed? Blanks are not allowed. Null is not allowed. Empty. Blanks are not allowed. Next one, salary. Then, so declared salary should be greater than what's it? 0. If you declare salary greater than 0, then what is not allowed? Negative values are not allowed. Every time you enter salary must be greater than 0. If salary is less than 0, then it is not accepted. So that means you don't need to write what's that? Programs. Okay, na? Then. So without writing the programs, you can check the data. You can validate the data. So you can guarantee what's that? Data quality. Data quality means, sorry, data is correct, quality is there. Data is not correct, quality is not there. So in this table, quality is there or not there? Not there, because this contains invalid data. Yes or no? So this contains some invalid data. So quality is not there. So how to maintain the quality? So in RDBMS, can we maintain the quality or not? Yes. Okay, then. Next one, supports data sharing. That means multiple users can access what? Multiple users can access the database at the same time. Database is not for single users. Database is Multiple users. Multiple users can access the database at the same time. Number of customers can log in to book my show, can book the ticket for same movie, same theater at the same time. Yes, because book my show uses RDBMS. Book my show uses what? RDBMS. Number of customers can log into IRCTC website, can book the ticket for train, same train at the same time. Yes or no? Because IRCTC uses what? RDBMS. Understood? That. So that means here the database can be accessed by multiple users. So sharing is possible. Next one. Supports what? Transactions like money withdrawal, money deposits, money transfer. These type of transactions can be easily implemented in RDBMS. Okay, na? Money withdrawal, money deposits, money transfer. This type of transactions can be easily implemented in RDBMS. So you use phone pay. Nowadays, what? How you do the payments? Like in tea stall or now tiffin center, how you do the payments wherever? Phone pay. Suppose you use phone pay. Okay, na? Then, so like phone pay definitely uses what's that? RDBMS. For the transactions, money transfer, transferring amount from one to another. For the transactions, then phone pay definitely uses what? RDBMS. Okay, then. So these are the what? Features. Okay, then. So first one, easy to access. How? Okay, now easy to access. How? Because here, so accessing manipulation is easy because we don't write what? Programs. You write commands. Okay, na? Non-programmers also can work with database. Next one, less redundancy. Duplication of data is what? Less. The data is not stored in multiple locations. Data stored in single location called server. And all the departments are connected to the server and access the data. Okay. Then more security. Only authorized users can access what? Database, but not unauthorized users. And guarantees what? Data quality. So you cannot store invalid data in what's that? Database. You store only the valid data. Next one, supports data sharing. So multiple users can access the same database at the same time. And supports what? Money related transactions can be easily implemented in RDBMS. Okay, then. So these are the features. Now, then, so like what are RDBMS? What are the RDBMS softwares? What are the RDBMS? Sir, here, what is OOPS? OOPS. Oh, that is full form. But what is OOPS is? OOPS is a concept. OOPS is a concept. What is Java? Programming language that support the features of OOPS. OOPS is theory. Java is the language support the features of OOPS. Okay, na? Like RDBMS is what? RDBMS. What is RDBMS? RDBMS is theoretical concept. RDBMS is what? Theory. What is the theory? So the data, you know that the data must be organized in tables. Every table must contain primary key. Next one, this one. Okay, na? So RDBMS is what? Theory. RDBMS comes with some features. Then what are the softwares implemented the features of RDBMS? What are the softwares implemented the features of RDBMS? OOPS is theory. Java is implemented the features of OOPS. Like similarly, what are the softwares implemented the features of RDBMS? One is what? SQL Server, Oracle, MySQL, DB2, PostgreSQL, like that. There are number of. Then so if anyone asks you what is SQL server, what is your answer? If anyone asks you what is SQL server, what is your answer? SQL server is a now SQL server is RDBMS software. SQL server is RDBMS product. Java is OOPS language. So SQL server is RDBMS software, RDBMS product. Okay, na? Then. So now, like suppose then, for example, top 10 what's that? Okay, na? Top 10 what? Then RDBMS. What are the top 10? PostgreSQL, MySQL, MongoDB, Oracle Database, MariaDB, Microsoft SQL Server, SQLite, IBM DB2, Amazon Relational RDS. Okay, na? Then one more is RDS. So what are there? They're from different companies. This is from what? Microsoft. This is from Oracle. MySQL is also Oracle. DB2 is from IBM. PostgreSQL also, company name is also PostgreSQL. This is from Amazon. Okay, then. So all these are like one family. What is that is? RDBMS family, but they belongs to different, they're from different companies. Okay. Then, so if you take OOPS now, like OOPS, if you take OOPS, what is C++, Java, C#.NET, C#.NET, next one, Python. What are these? All are what? Same family, OOPS family, but they are from different companies. So this is from some like ANSI, like Java is from Java, Oracle, C#.NET, Microsoft, Python Arc. Okay, then. So they're from different companies. Like RDBMS also, they're from different companies. Okay, then. So in SQL Server, how you store the data? In SQL Server, how you store the data? Tables. In Oracle, how you store the data? Tables. Because they are RDBMS. Because in RDBMS, you store the data in the form of tables. That's why in all this, you store the data in the form of tables. And if anyone asks you, tell me some features of SQL Server, then if anyone asks you, tell me features of SQL Server, give this list. Because there are features of RDBMS. SQL Server is also RDBMS. Then give this list. In RDBM, in SQL Server, accessing manipulation is easy. SQL Server, redundancy is less. SQL Server, security is more. SQL Server supports data quality. SQL Server supports data sharing. SQL Server supports transactions. If they ask you, tell me the features of Oracle, then give this list. So it is common to what? All or DBMS. Okay, then now. Okay. But here, sir, here just one more is that. What that is? What that is? What the BMS? What is what the BMS is? Then object what? Relational DBMS. Then what DBMS stands for? What DBMS? What DBMS stands for? Object Relational Database Management System. Okay, na? Then so you can say it is a combination of what? RDBMS and OOPS. That means RDBMS is equal to RDBMS plus OOPS. To the existing RDBMS, some extra concepts are added, and extra concepts are related to what? OOPS concept. To the existing RDBMS, some extra concepts are added, and extra concepts are related to OOPS. What is the main concept of OOPS? Sir, actually, OOPS is introduced because of two reasons. One is, what is security? Another one, reusability. This is the main concept of OOPS. Security is not required. Security is not required from OOPS. Why? Because RDBMS provides security. We don't need security from OOPS. What is taken from OOPS? Reusability. That's then what is taken from OOPS is reusability is taken. What the difference is? RDBMS what? RDBMS what, sir? Doesn't support reusability, but RDBMS supports what? Reusability. That's it. This is the difference. So reusability feature is introduced, and they introduced a new DBMS called RDBMS. But how it is introduced, how it supports reusability, we'll see that after going to the actual SQL server. We'll see that. Okay, now then we create some types, we reuse the types. Okay, then okay, now then. So like then suppose here then so what are the examples here then? So what are the examples for what DBMS is then? What DBMS examples? Okay, then see, SQL server supports what? SQL server supports what DBMS? Oracle supports what? What DBMS? So PostgreSQL supports what? What DBMS? Okay, now then. So all this supports what? RDBMS. Now, if anyone asks you, what is SQL server? Huh? Oh, what is SQL server? SQL server is basically RDBMS product and also supports features of RDBMS, and it is used for what? What for it is used? Huh? What for it is used? To manage database. If any company wants to manage the database. Sir, here, once again, listen this. Here, actually, see, database is there. To manage this database, you need a software. What is that software? What I said? What is the software? DBMS. Database is there. To manage the database, you need a software. You cannot directly work with database. You use a software to work with the database. What is the software? DBMS. So DBMS manages database. So DBMS. What type of DBMS? What type of DBMS? RDBMS. Okay, na? What type of DBMS means? RDBMS. What RDBMS? SQL server. Okay, na? So company manages database by using DBMS. What type of DBMS? RDBMS. What RDBMS? SQL server. Understood? Then, sir, here, see, once again, sir, daily I come to Naresh IT by using what vehicle? Which vehicle I use? Two-wheeler. Which two-wheeler you use? Honda Activa. Then suppose, like, let's see, for example, like company, how company maintains database by using DBMS. Which DBMS? RDBMS. Which RDBMS? SQL server. Then, okay. So this is more what's a general, like DBMS. Okay, then you can compare this. So this is one of the type. Okay, na? Then, so this is type. But here, then what's that? What is the example for two-wheeler? One of the example is what? Honda Activa. So what is the example for RDBMS? SQL server. Like that. So then, so if anyone asks you, like, what is SQL server? Now answer is SQL server is what? Basically a RDBMS product from Microsoft and also supports RDBMS features and use it to create and to manage database. If you want to create the database, if you want to work with the database, we use a software called SQL server. In your laptop, you want to create a database. Okay, na? Suppose there is a what? For example, you want to develop a database for Naresh IT. To develop database for Naresh IT in your system, then first you have to install what? First you have to install what? Okay, na? Then first install what? OS is already there. Suppose assume. Then first install SQL server. After installing SQL server, then create what's a database. Create the database and work with the database. But to create the database, to work with the database in your system, compulsory you need to install SQL server software. Then, okay, then. So this is what is what like RDBMS and ORDBMS. Okay, then you don't need this. You don't need this. You need what? These two. Next. And before going to the actual SQL server, you need one more topic. What that is, like we'll see that in the next class. But what the topic is, database, what's that? Development life cycle. Database development life cycle. In database development life cycle, we'll be discussing what are the various roles in what's that? Database development. In database development, so what roles are there? Okay, na? So what are the different phases in database development? In each phase, what are the activities in each phase? What are the different phases in development? So what are the in each phase, what are the activities and what are the roles? And we have to perform that activities. Okay, that we'll be discussing. So it takes one class. Then after completing that, then we can start SQL server. Okay, na? Because before going to SQL server, if you have this idea, then definitely it is good. Okay, then. So next class is Monday, because some new students are added on Monday also. So that's why like only this Saturday, not every Saturday is holiday. Okay, na? Only this Saturday. Then. Huh? So next class is Monday. So okay, we'll continue this tomorrow. Monday. Sorry. Uh, hmm. uh, uh. But they create the Google class after 2 or 3 days. Once after creating, I'll every day I'll upload. Okay. Yeah. Uh, definitely. Uh, ఏంటది మీకు కావాల్సింది వీడియోస్ అంటే దెన్ యూ హావ్ టు సపరేట్లీ రిజిస్టర్ ఫర్ వీడియోస్. ఓకేనా? అదే వీడియోస్ కావాలి అంటే మీరు వీళ్ళని కాంటాక్ట్ కావాలి. ఓకేనా? ఎస్. See, online students, I'm sending the notes to the chat box. Okay, na? Then I'm uploading the notes in chat box. Okay, then. But once Google class is created, then I'll add it to the Google class. But at present, I'm uploading these notes to the chat box. Then, so you can same Ram Gopal, same. In RDBMS, what is primary key means same. So primary key not changes from RDBMS to RDBMS. Bindu, it is same. Huh? Oh. క్లాస్ నోట్సా? దెన్ వీళ్ళకంటే ఇక్కడ యాడ్ చేస్తాను, మీకు ఎలా యాడ్ చేయాలి అదే. Then you have to wait for some 3-4 days till they create Google Class. Once it is created, then every day I'll upload. At present, just note down. So just 3-4 days. Huh? See, object, don't go to that object level. Here we don't create objects. Okay, na? Then Bindu, even though it is what DBMS, it is not object oriented, it is object relational. Okay, then Sudhakar, he'll understand this. Like within next 1 or 2 days, he'll understand what is cloud server, what is database. Then Bindu, it is not object oriented, it is object relational. We create tables only here. Okay, na? Then we don't create objects, we create tables only. In tables, there is a primary key. What is the difference? No difference. Primary key is same for RDBMS or ORDBMS, because in RDBMS data stored in tables, ORDBMS also data stored in tables only. So there is no difference. Sir, huh? Okay, okay. చేస్తున్నారా? ఓకే, ఎక్కడ? ఓకే, అవును, ఓకే. ఇప్పుడు దేని మీద? ఎక్సెల్? ఇప్పుడు ఎక్సెల్ యూజ్ చేస్తున్నారా ఎక్కువ? ఎక్సెల్, ఓకే. చాలా ఉంటాయి ఎక్సెల్, అసలు మిగతా వేటిని కంపేర్ చేయలేము అసలు ఎక్సెల్ తోటి. ఎక్సెల్ లో ఉన్న ఫీచర్స్. ఆహా, 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 ఈజీయే కొంచెం. మీరు ఒకసారి యూట్యూబ్ లో ఉంటాయి చూడండి. వి లుకప్, హెచ్ లుకప్, పివోట్ టేబుల్. ఓకే, ఓకే, ఓకే. ఆహా, ఓకే, ఆహా, ఓకే. ఓకే, 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 ఓకే. విజయ్ కుమార్, విజయ్ కుమార్. కే, కే, ఓకే. అంటే మేబీ ముగ్గురు ఉన్నారు ఫ్యాకల్టీస్, ఎవరో మరి తెలియదు నాకు. మేబీ ఏ టైం అండి? 7? వాట్ ఈస్ ద స్లాప్? స్లాప్ మీన్స్ ఐ డోంట్ నో. ఆ, ఆ, 7:15 అంటే మిస్టర్ సతీష్ గుప్తా. ఓకేనా? ఈసారి కూడా మంచి సార్, బాగుంటుంది. ఎస్, నేను తీసుకుంటలేను. ఓకే, బాగా చెప్తారు మీకు, నో డౌట్. ఏం లేదు, డెమో అది అసలు, అంటే ఏం లేదు, వాట్ ఈస్ వాట్ అంటే ఏం లేదు. ఆ, ఈ రోజు కూడా మీకు ఉమ్, అంటే తీసుకోవాలంటే మరి వాళ్ళని అడగాలి వీళ్ళని. ఓకేనా, అండ్ సపరేట్. ఎస్. ఫస్ట్ మీరు వాళ్ళని కాంటాక్ట్ కండి, వాళ్ళకు మీకు ఐడియా మీకు ఏంటని చెప్తారు. సపోజ్ ఆబ్సెంట్ అయితే ఎలా అని. అదే అదే ఓకే, వాళ్ళని అడిగితే చెప్తారు, మీకు సొల్యూషన్ ఇస్తారు. ఓకే సార్. ఓకే ఓకే. See, Rajesh Kumar, this is for analysis, the database which is used for data analysis. Okay, then. So there is one database for storing day-to-day transactions, one database for analysis. OLAP is for analysis, but data analysis, they use OLAP. కూర్చోవచ్చు. ఓకే. 30 years లేదులేండి. ఓకే. 15 ఉంటుంది. ఓకే. ఉంటాయి. ఓకే దెన్. ఓకే గైస్, బాయ్, see you on Monday. So next class is on Monday. Bye. Mhm. Uh-huh. So that is all related to data warehousing, MSBI. Okay, na? Reporting, integration, analysis service. They're all related to MSBI. Yeah. Okay, na? Okay then.